flow definitions. Maximum flow or maximum probable possible flow, is that which will occur if outlets on all pictures were open simultaneously. Sabay-sabay. Average flow is that flow likely to occur in the piping under normal condition. Maximum probable flow is the maximum flow which will occur in the piping under peak conditions. It is also called peak demand or peak flow. Peak flow, probable flow is the same. It is different from maximum flow o possible flow. Yung lahat, possible flow is lahat bukas siya. Itong maximum probable flow, maximum to ng halos sabay-sabay. Yung maraming ang gumagamit pero hindi naman siya lahat ng outlet sabay-sabay kasi hindi naman pwede yung nagbabathtub na gumagamit ng water closet, di ba? So, lahat ng tao gumagamit pero yung fixtures hindi niya gamit lahat. Average flow is pwede sa isang araw, yung average flow rate niya. Kasi minsan wala namang gumagamit at 8 to 10, 8 to 10 may gumagamit, 10 to 11 wala, 11 to 12 meron. So, ang average nun, yun yung average flow. Maximum probable flow, ito yung consider natin as design peak. Kasi imposible kasi magsabay-sabay yung outlet. Okay? Demand types. So, some outlets impose what is called continuous demand on the system. They are differentiated from outlets which impose an inter-demand or intermittent demand. Outlets such as hose beams, non-irrigation, air conditioning, make-up, water cooling, and similar flow requirements are considered to be continuous demand. Kasi pag inandar mo yung aircon, sigurado may tumutulo. Continuous. So, hose beam sa garden, di ba? Pagka mo, diretso yan. Floor irrigations, yan. Make-up, continuous yan na open. Yeah. So, in similar flow requirements, they occur over an extended period of time. Yeah. Gardening, make-up, sa water cooling, yeah. Plumbing fixtures grow water for a relatively short period of time and are considered as imposing an intermittent cut demand. So, di ba bawal yung mag-ugasan ng pinggan, tuloy-tuloy yung yung tubig. Kasi hindi wala kang plato, tumutulo pa rin yung tubig. So, hindi pwede yan. Hindi mo pwedeng continuous. So, pag nag-ugas ng plato, you-on, off, on, off mo yun. So, each picture has its own singular loading effect on the system, which is determined by the rate of water supply required, duration of each use, and the frequency of use. The water demand is related to the term of fixtures, types of fixtures, and the probable simultaneous use. So, each fixtures, meron silang gallons per minute na nakalaan dyan. So, estimating demand. The basic requirements for estimating demand calls for a method that A, produces estimates which are greater than the average demand for all fixtures or inadequate supply will result during period of peak demand. B, produces an accurate estimate of the peak demand to avoid oversizing. Yan. Yung estimate ko dapat hindi mag-oversize, hindi rin magkulang. C, produces estimates for demand of group of the same type of fixtures as well as for mixed fixture type. So later, malaman nyo kung ano yung mga baldong ilalagay dyan. So design load, ito na. Arriving at a reasonably accurate estimate of the maximum probable demand is complicated due to the intermittent operation and irregularities. Okay? Intindihan nyo yan. Different types of kinds of pictures are not in uniform use. Bathroom pictures are most frequently used on arising or retiring, ibig sabihin pagbangon, or kapag tulog. And not surprisingly, during TV commercial. Pag may commercial, so tuligo ka. Kitchen sink finds TV use before and after meal. Bugas lang nga. Laundry trays and washing machine are most likely used in the late morning. During the period from midnight to 6 p.m., this is there is very little fixture use. Tulog ka, kung magigising ka lang, ka, ito ka lang gamit ng flash. O yung tubig. Mag-ilamos ka. Emergency lang. Luckily, fixtures are used intermittently and the total time in operation is relatively small, so it is not necessary to design for maximum potential load. So, yung faucet, laboratory, may nakita ang table ng mga gallons per minute. Ito total mo yan para yun ang ibig sabihin ng maximum potential load. Pero hindi yun ang peak load mo. Design load mo, hindi yun. Mas mababa. Maximum flow is therefore of no real interest to the designer. Average flow is also of no concern. For if a system were designed to meet this criterion, it would not satisfy the condition under peak flow. Okay? So sa design ng piping, that is, gagamitin mo is yung peak flow or yung maximum probable flow. Sa design naman ng tanke, simple, average flow gamitin mo. So it is therefore necessary to consider only the maximum probable demand with demand imposed by the fixture on a system. So topic natin is designing yung piping. Okay? Sa tanke, simple average gamitin mo nga. Two methods have evolved in the United States noon, which when used, when each is applicable, have proven to give satisfactorily. They are the empirical method and the method of probability. The empirical method is based upon arbitrary decision arrived at from experience in judgment. It is useful only for small groups of fixtures. The method of probability is based upon the theory of probabilities and is most accurate for large group of fixtures. This theory of probabilities, ito yung source ng fixture unit method. So ito yung sabi kong demand. Demand at individual fixtures. Certain demand rates have become generally accepted as standard. Standard lang. So, sa mga modern, mga faucet ngayon, mayroong mabababa. Okay? Pero sa design, ito gamitin mo kasi hindi mo naman malaman agad kung ano yung gagamiting brand, type ng faucet niya, o bathtub, anong bang gagamitin. So, designer ka eh. The rates are tabulated in table 2 for the common types of fixtures and the average pressure necessary to deliver this rate of flow. The actual pressure for the specific fixture will vary with its manufacturer's design. Yan. Some requiring a greater or lesser pressure than others. So ito yung table 2. Ito yung fixture mo, ordinary lavatory faucet, self-closing lavatory faucet, sink faucet, create ang pipe, ang size ng gripo. Sink faucet, one-up naman. Bathtub faucet, laundry tub faucet, shower head, water closet plus tank, water closet plus valve 1 inch. So iba ito yung may tangke, ito yung valve lang. Nakita niyo naman to sa section natin. Urinal plus valve, ito yung common ngayon, 3/4 inch. So hose bib or seal cap, 3/4 inch. Ang flow pressure niya is normally ito nga. Ang faucet normally 8. Sa iba, lahat yan 8 except doon sa water closet. Ito sa ibang source. May 12, may 10, 5. So kaya ito ang dapat, kung nag-calculate ka, ito ang dapat lumabas na pressure mo. Design pressure. Kaya kung gravity lang, mauubos yung pressure mo. Pag labas mo dito, zero na. Okay. Kung na-compute mo dito sa flow test, negative, sabihin, hindi na lumalabas yung tubig mo. Flow rates, ito yung design flow rate mo, 3 GPM, 2.5. So, ito. Ang dapat lumabas doon sa bawa, ito sa faucet mo yan, 4.5 GPM. Sa iba, 3 GPM to. Sa iba, 5 GPM. Depende sa source mo. Sa ibang code. Kumbaga, design value mo yan. Then, Now, di pa pala to, push. So although the flow ratio in table 2 have been accepted and are widely used by many engineers, especially designers, they are hopelessly outdated. Drastic changes and progress in fixtures and faucet design have occurred through the years since the establishment of this criteria. Laboratories have been installed in hundreds of buildings that require only 1 GPM, so meron namang mababa ang flow rate. Shower head are available which delivers GPM 3 to 5, diba? Flow control devices are now marketed which accurately deliver any selected rate of flow under varying pressure condition. More research is needed to determine accurately the actual minimum flow required at each type of fixtures to satisfy psychological requirement of the user and to provide adequately the necessary sanitary requirement. So this is the design, pressure, and flow rate. So meron ka namang makikita sa ibang code na this is 60 PSI at wala nyan gallons per hour. That is yung rating ng faucet mo. Di ba? Para di pumutok. Okay? That is the maximum. Pero design pressure mo ito. So hindi mo pwede gamitin yung wala dito, di ko dinagay. Yung 60 PSI rating ng faucet mo saka yung flow rate niya. Yung iba na misinterpret, yun ang pinapadesign 60 PSI. Saan ko kukuha ng 60 PSI? Diba? Sa ibang bansa, mayroong malakas ang pressure. So, kino-consider na yun. Pero ganun ang pag-testing ng faucet, gawin nyo ng 60 PSI kung di puputok yung faucet mo. So, normally, ito yung design pressure. Design pressure. The 60 PSI is the maximum pressure. So, abot na to. Kung ang pressure, ang halimbawa, 8 PSI na ginagamit ko sa mga faucet, tapos 15 PSI sa water glass ginagamit ko. Halimbawa itong USB, pwede rin itong maging 15 sa iba. Pero 1 up to. Okay? May ibang table dyan. Well, 8 PSI yung pressure mo required. Tapos yung pressure drop mo, kasama ng elevation, is 10 PSI. So, i-add mo dito, that's 18 PSI. Ito yung required pressure after doon sa pump mo. Magpa-pump ka kung ang supply mo, kung ang main mo is mababa, 10 PSI, ano minimum, 10 PSI. So, meron kang 8 PSI na head sa pump. Pero dito sa atin, minsan walang tubig. So, masyado mababa. Kaya pina-assume na lang na 0. Or minsan, later malaman kung bakit 0 din nilalagay ko. Kasi gagawa ka ng tangke. Tapos yung papasok sa pump, saka naman pupunta sa piping, punta doon na sa faucet. So, ibig sabihin, pag galing sa tank, approximately 0 ang initial pressure mo. So, ibig sabihin, 8 plus 10, 18 PSI, yun din ang pressure, total dynamic head mo. Yun ang gagamitin mong pressure sa pump selection. Plus yung, iba yung flow rate. Si flow rate and PSI head or total dynamic head, makukuha mo yung horsepower. So, yung dalawang yun, in combination ng dalawang yun, plus may isa pa pala, yung efficiency ng pump. Depende sa paggamit mo, so the product ng flow pressure sa flow rate divided by ng efficiency, makukuha mo yung horsepower ng pump motor mo. Okay? Then, next, water supply fixture unit. Doon sa drainage, that is drainage fixture unit. Ito naman, water supply fixture units. So, a standard method for estimating the water demand for a building has evolved through the years and has been accepted almost anonymously by plumbing designer. It is a system based upon weighing fixtures in accordance with their water supply load producing effect on the water distribution system. The National Bureau of Standards has published report BMS 65 methods of estimating loads in farming system by the late Dr. Roy B. Hunter, which gives tables of load producing characteristic or fixture unit weights of commonly used fixtures along with probability curve, which make it possible to apply the method easily to actual design problem. So water supply fixture unit values for different kinds of fixtures as given in table T or are given. So this is the water supply fixture unit values. So sa itong una, sa Philippine Mechanical Engineering Code, so dito yung water supply fixture unit, WSFU, and minimum fixture unit runs 5 sizes. Minimum. So appliances, appurtenances, or fixtures, andito siya. Bata, bidet, clothes washer, rental unit, dishwasher, drinking from hose bib. Ayan, may hose bib na 1/2. Dito ang option mo is may 1/2. 1/2. Doon kanina, 3/4, di ba? So ito yung, so example na ito. And for private use, for example, sa common tayo, common. Laboratory. Ito, laboratory. So 1/2 ang, ano mo, ang gripo. So 1 ang ano mo, 1. 1 double SFU or FU. Then, so, pag public, that's the same, 1. Pag assembly, this is also 1. Okay? So, dito tayo sa isa. Clinic, dosimeter valve, so public. 8. Okay? Domestic, kitchen, same 1.5. So, dito, assembly, okay, kung wala naman, dito ka na kumuha. Urinal, ayan. Water closet, dosimeter tank, so ito. So, dosimeter valve may note put number 7. So, ito different ang approach dito. So, note 7, when sizing dosimeter system, see section 1410.10 meter. Ito yan. Iba yung table niya. Pag may valve, water closet, saka urinal. Tapos, may note dito. This is the size of the cold branch or both the hot and cold branch pipe. So the same hot and cold. Hot water piping and the cold water pipe. So basahin nyo lang mga notes. Malabo mata ko. Ito, the listed fixture unit values represent their load on their cold water service. The separate cold and hot water fixture unit values for fixtures having both hot and cold water connection may each be taken as 3/4 of the listed total value of the fixture. Yeah. Mawa ito. Laboratory. May hot and cold ka. So, ibig sabihin, sabay. So, lalagyan mo yung hot, 0.75 kasi 3/4 ng 1 eh. Di ba? So, yung sa cold naman is 0.75 fixture unit, FU. That is 3/4 nung listed. Pag yung dalawa, meron doon. So, yung next table, ito is sa plumbing code. So, ayan. Private closet sa mga flush tank. Ayan, may asterisk. Dosimeter valve. So, asterisk. Asterisk. Ito rin sabi niya, subsection 609.9. So, ito yung sinasabi. May asterisk na yan. Yung notes para sa dosimeter valve. So, pulsometer fixture unit for water sizing using the table. So, ito yung, ano niya, picture categories. For example lang, dito tayo sa picture unit sa water closet. Same din sa urinal. So, pag meron ka sa branch mo na isang water closet na may pulsometer valve, ang lalagay mo doon 40. Hindi ito. Meron ka dito as 2.5, hindi 2.5. So, gagawin mo is 40. Pag nagdalawa, pagkasunod, may isa kasunod, hindi 80. Pag ilan mo yon, yung additional doon is magiging 70 na, yung dalawa. Pag nagtatlo, magiging 90. Pag apat, so magiging 105. Pag lima, 115. Pag sobra pa, pag 6, so dadagan ng 10, magiging 125. Tapos 10, 10, 10 na lang. Okay? Kaya yung pag-compute mo, ingat na. Sa urinal, ganun din. 20 yung unang isa, pangalawang isa, 35. So, pangatlo, pag nagtatlo, 45. So, pag may isang water closet na may valve, tapos picture urinal na may plus valve din, i-add mo lang yung dalawa. Yun lang yan. Wala namang note. So, next table, sa plumbing code din ito. So, dito, pinaghiwalay niya na yung hot and cold. Ay, this is the minimum collection. So, ganun din. So, dito, meron siyang value sa pulsometer valve. So, pero mas sundin pa natin itong isa. Ito mas malaki ang size nito kasi. Hindi ko alam kung saan kinuha ng plumbing code ito. So, yeah. Pag marami yung ano mo, pwede rin to. Pag konti lang, ito gamitin mo ng water closet. Pag marami yan ito. Kasi nag-average na lang siya dito sa 10, 6. Diba, siguro reference niya dito. So, basahin niyo yung mga note. So, ito naman, conversion. Ito naman tayo. So, conversion of fixture unit values to equivalent gallons per minute based upon the theory of probability of usage. Kaya nga, base ito sa theory of probability. Is given is in table 4. A graphic representation of this table is shown by figure 1 and 2. Hunter's curve, ang tawag doon. An examination of the curve and tables reveal that the demand for a system utilizing plus tank is much cheaper than for plus bulb for small quantities. The difference in demand for each system decreases as the fixture unit load increases until 1,000 FU are reached. At this losing and beyond, the demand for both system is the same. Ito yung binabanggit niya. Yan. 1,000 or more. Malapit ito. Bisa mabot ng 1,000 nga, mga 800 lang. Pero more than 1,000 at sigurado na same siya. Okay, better. So this is from National Standard Plumbing Code, illustrated. Meron din ito sa PCME Code, Mechanical Engineering Code 2012. Kaya lang ito yung ginamit ko, since alos pareha sila, mas malinaw. Diba? Kasi yung pagka-picture ko doon malabo. Wala kasing soft copy ng yung Mechanical Engineering Code. Bawal yon. So, halos the same siya. Yung column ng plus tank, ito yung ordinary. Yung column ng GPM plus valve, ito yung may pulsometer valve. Pag mayroon kang pulsometer valve, ito yung gagamitin mong table. Diba? Sa branch. Pag naluan na siya, yun ang gamitin mo. Diba? So, for example, nung nakuha mong WSFQ 3, so 3 GPM ka. 4 GPM, 4.5. Bawal, ito, better kasi may example naman. Example, may tatlo kang nag-total ka ito. Meron kang water closet, meron kang urinal, meron ng laboratory, nag-total ka ng 10. Nasign mo to, linagay mo ng picture unit yan. Ito, ginamit mo. So, i-add mo yon, naglabas ka ng 10, dito ka. 8 GPM ang equivalent nun. Diba? Hindi yung dalawang 5, 8, yung, ano to? 10 GPM, diba? So, 8 GPM. Okay? Hindi yung 5 GPM, 4.5 GPM. Ano ba yun? Sabihin, hindi mo ito total yung gallons per minute na nakita mo doon. So, hindi mo ito total. So, total mo is yung water supply picture unit, tapos hanapin mo siya ng equivalent gallons per minute kasi maliit yun. Makalo, 10, naging 8 GPM. So, dagdagan mo ng, naging 12. So, that is 9 GPM. So, 1 GPM na nadagdag. Hindi ode. So, 10, dagdagan ka ng 3 water supply picture unit. So, 10 plus 3 is 13. So, this is 10. So, 8 doon. Ilan na dagdag? 2 GPM. So, ibig sabihin, nagdagdag ka ng 3 water supply picture unit. So, yung dinagdag mo is 3. So, 3 plus 8, dapat 11. Pero, ang sa table mo, palabas is 10. Okay? So, lumiliit yan. Ang gallons per minute mo. What, 10? Nagdadag ka ng 10. Water supply picture unit. 20. So, ang tapat is 14 GPM. Hindi yung 10 GPM, 10 water supply picture unit, 8 GPM. So, times 2 mo, 16. So, hindi. Sa baba. Okay? Later, sa example natin. And kung ano naman, yung meron kang glass bulb, so yung nakuha mong 10 WSFU, ang equivalent naman nun is 27 gallons per minute. So, ito ang gagamitin mong gallons per minute doon sa pipe sizing. So, ibig sabihin, mas malaki yung pipe size ng may glass bulb. Kasi 1 inch ang yung connection niya. Okay? Ayan. Pagdating dito, so mag-equal na siya. Diba ito? 1,000, both are 210 gallons per minute. Yeah. So, mas mura yung plus tank. So, itong figure, ito yung inner scale, ito yung normal scale, then ito yung inner scale, itong part na to. So, check na lang yung notes. Ito pa lang, SI units, 1 gallon per minute is 0.06 liters per second. Or, ang yan is 0.063 liters per second. Now, so figure 5, ito yung extended. Ito expanded, ito yung extended. Extended yan. Okay? Mixed units na siya. May plus meter valve or wala. Now, this student is again warned that he must use the table of picture unit values in the code applicable to the locality of his project. So, kaya, yung gamitan is sa mechanical engineering code, saka yung pinasit ng table is parehas lang ng ang labas. Kasi doon din yata yung reference na. Pero may ibang table na ibang-iba. Mas malaki. Yung Illinois Plumbing Code. Iba doon sa kanila. Okay. The student is also alerted to the fact that the water supply fixture unit are not the same as drainage fixture unit values. Iba yun ha. The discharge rates of certain fixtures are entirely different than the rate at which water is supplied. That is bathtub. The loading effect is therefore different on the drainage than it is on the water supply than it is on the water supply for fixture unit. So, nadoble yata ito. Wait ha. So, The following example illustrate the procedure for sizing a system. Sample. Determine the peak demands for hot and cold water and the total water for an office building which has 60 plus valve, water closet, 12 wall hang urinals, 40 lavatories, 2 hose bib, and requires 30 GPM for air conditioning, water, makeup. Right. So from table T2, determine the FU values. This is the solution. Yung format natin, ganun ka na. Given problem, given required solution. Okay? Ito is for explanation lang. So, the table, gawa ka ng table, 60 water closet. Okay, hot water, cold water, total. So, 60 water closets times 5, saan 5? Water closet is ito, 5. Crucimeter tank tayo. Public pa yan? Public yata. Okay? So, 12 urinal is 3. Assuming na plus tank. So, that is 3. And, wala. Okay. Ito na. Then, 40 lavatories times 2. 40 lavatories times 1.5. Itong 2 is for the total. Okay? 2 fixture units is yung 2. Ang total ng listed niya is 2. Ito. Yun ang ginamit. So, gagamitin mo to sa total lang. Okay? So, 40 lavatories times 1.5 sa hot water and cold water. Kasi 3/4 ng 2 is 1.5. Okay, nagets niya. Kaya yan. 60 water closets times 5 is 30. Wala namang hot water sa water closet. Gusto nyo bang lagyan? Inidoro, supply ng mainit. Wala. So, dito lang tayo sa cold water. So, lalabas, total mo is 300. Urinal, ganun din. So, wala namang hot water supply doon. So, kaya 30 times 3 is 36. So, 36. Lavatories meron. Diba? Hugas ka ng kamay. So, the total muna tayo is 40 times 2 is 80. So, individual, 40 times 1.5, so 60 sa hot water, 60 sa cold water. Dito wala na kasi ito na yung total na 80. And some hot water is 60 FU, cold water 396 FU. Itong FU na to is water supply pressure unit. Kesa WSFU, palagay natin FU na lang. Kasi mag-compute ka. Magawa ka na lang. The total ng hot and cold is 300 plus 36 plus 80 is 416 fixture unit. So, yan. Hindi siya magtatali, ha? So, from table 3, that's 5 or figure 4, yung 60 FU is 33 GPM hot water demand. Ano yan? Ito yung figure, hanapin mo dyan. Dito mo edit na yan. So, pwede ka rin gumamit nito. Chain large. Okay? Ano yan? 60. 60 is 33. Plus tank tayo. Kasi yung plus tank lahat. So, 33 GPM ka hot water demand. Then, 396 FU. Hanapin mo dito. 396. Yan. Interpolate mo siya between 85 and 105. This is 104.2 gallons per minute cold water demand. Okay? Sumbang mo naman ng isang decimal point. So, 416 FU is 108.2 total water demand. 416. Same ang range mo rin. 105 to 125. So, yan. Ito na yung gallons per minute mo. To the cold and total water demand must be added the continuous demand. So, 2 hose wave times 5 from table 2. Hanapin niyo yung table 2. Ano yung continuous value ng hose wave? So, 5. Table 2, dito ba? Nagmamagumak dito. Hindi na. So, sa ibang slide na lang tingnan nyo. 5 GPM yan. So, this is 10. 2 times 5. So, air conditioning makeup, sinabi dito is 30 GPM. So, ito yung i-add mo, 40 GPM. Then, the total hot water demand is 32 GPM. Cold water demand is 104.2 plus 40 is 144.2 gallons per minute. And total water demand is 108.2 plus 40 or 148.2. Ito yung mabasayan mo ng size ng piping. Total water, tapos mag-separate siya. Ito ng hot sa cold. Okay? So yan, ito yung design GPM mo ng pipe. Okay, the conversion of fixture unit load to equivalent gallons per minute was obtained from table 3.5 using straight line interpolation to obtain intermediate values. Ginawa na nga natin. So the total water demand is required for sizing the water service line for the building and also for the cold water piping inside the building up to the point where the connection is taken off to the hot water heater supply. Yeah. Tapos, ito naman, if the water closet and unit are both plus valve type. Yan. So, ano na? This is, hindi pala sinabi yung ano. So, 60 water closet. Lampas tayo. Ito yun. So, same ano? Yun na. Sa hot water, okay lang to. 40 times 1.5. 60 FU. So, sa cold water, for 60 water closet, ang fixture unit mo is ito. Table. Table. Asan yung table? I-insert ko lang yung table. Pause tayo. So, ito yung table for Prosometer fixture unit for water sizing. For 60 water closet, ilan yan? 60. So, lampos ng 5. So, 60. 115 plus 60 times 10. So, ito yung fixture unit mo. 115 plus 10 times 60 minus 5 pala. Kasi in excess of 5. So, this is 665. So, lagay mo dito 665. Sa urinal naman is 60 rin. So, 60. Kaya 60 minus 5 times 5, 5 plus 58. Yan. So, magiging 333. So, tagay mo dito. 333. So, add mo na. So, total hot and cold, 665 sa water closet. Urinal, 333. Lavatory, 80. Then, so, wala sa, ano, ito sa last row. Okay? Add mo to 60 picture units hot water. Cold water is 1,058 picture unit. Total hot and cold is 1,078 picture unit. So, from table 3.5 or figure 4, siyempre 60 FU is again 33 GPM hot water demand. So, cold water mo is 1,058 picture unit or 211.4 GPM cold water demand. Ito. 1,000 and 1,250 in between. So, interpolate mo na lang. Makuha mo yung GPM dito. Since 1,000 more, so parehas lang siya, di ba? Yeah. 1,078 pixel unit is 211.9 gallons per minute total water demand. So, dito din siya. Sa table din to. Yeah. So, the cold water and total water demand must be added to be continuous demand. So, 2 hose beams times 5 is 10 GPM. Air conditioning makeup is 30 GPM. Total of 40. Then, the hot water demand is 33 GPM. So, cold water demand is 211.4 plus 40 is 251.4 GPM. Now, the total water demand is 211.9 plus 40 or 251.9 GPM. Now, if the water closet is tank type and urinal is flush valve type, ito yung madalas ngayon kasi makita mo yung mga urinal lang tangke. Flush type na yun. Flush valve na yun. So, from table 3.2 and 3.3, determine the FU values. So, water closet 60 times 5 is 300. Total 300. Sa urinals lang tayo mag-adjust. 12 urinal is 58 plus 5 times 60 minus 5 is 333. So, cold water siya, 333. Total is 333. Lavatories, 40 times 2 is 80 sa total. 40 lavatories times 1.5, 60 sa hot water and 60 sa cold water. Then, total ng hot water is 60 FU. Cold water is 690 pixel unit. And then, total ng hot and cold is 713 pixel unit. So, from table 3.5 or figure 4, same din sa 60 FU sa hot water is 33 GPM. Hot water demand, 693 pixel unit is 167 GPM. Cold water demand, so dito siya, 693. Nasa na? Ito, hanapin mo yung 693 between 500 and 750. Interpolate mo siya dito sa plus tank. Okay, hindi ito. Ito kasi plus tank. Itong isa. The value is 167 gallons per minute cold water demand. Then, 713 pixel units sa total. Ang equivalent naman is 169.8 gallons per minute total water demand. Now, to the cold water and total water demand must be added the continuous demand. So, 2 hose beam times 5 is 10 GPM. Air conditioning makeup is 30 GPM, total of 40 GPM. Then, the hot water demand is 33 GPM. Cold water demand is 167 plus 40 is 207 GPM. Total water demand is 169.8 plus 40 is 209.8 GPM. Yan ang sagot mo. Ito muna isa-size yung pipe mo. Note, di ka pa nabanggit, sa cold water maximum is 8 feet per second velocity and hot water is 5 feet per second. Minimum pressure. So, balik tayo sa minimum pressure. So, sa table na to, kanya, di ba, yung mga fixed minimum pressure niya dito. Ito. Ayan. Itong flow pressure. Ito yung i-discuss natin naman. Marami itong slide. Basic lang to para pag na-actual na kayo, meron kayong reference. Minimum pressure. The water distribution system must always be designed on the basis of the minimum pressure available. Sa source, the source or pressure may be the public water main, gravity tank, hydro pneumatic tank, or booster pump. Hydro-pneumatic tank, ito yung may pressure tank. Yung booster tank, so pag kulang yung gravity tank, magdadagdag ka ng booster pump. The normal pressure available from the public main can be obtained from the local utility. Normally, 20 pesos sa atin, pero minsan nawawala, mababa. So, kaya minsan zero na lang. As indicated previously, it is good practice to assume minimum available pressure to be 10 psi less than stated pressure. Pero pag declared value, 20 psi yung main, so minus 10 ka, yun ang magiging supply pressure mo, suction pressure, tawag. Suction in discharge, di ba? Sa pump. When a gravity tank is the source of pressure, the low water must be used for design. So, lowest level ng tanke. So, depende sa elevation mo. And then, so pwede mo siyang assume na zero. Note, pag may gravity tank, dapat mga 30 feet yata above para makakuha ka ng minimum pressure doon sa faucet. Pag naka-level lang siya sa roof deck, pinatong mo lang, so hindi sa overhead, katapat mo. Ang overhead tank is yung siyempre above sa ulo mo. Yung makita mong matataas sa tangke. Elevated. Yan. So, hindi elevated ang nasa roof deck. Kasi pag pumunta ka ng roof deck, ka-level mo yun. Nalagay kasi nila overhead o elevated water tank kasi naka-elevate sa building. Pero pag pumunta ka sa roof deck, katapat mo yun. Saka yung roof deck, sa ilalim nun, andun yung mga faucet mo, highest faucet mo, o yung fixture mo. So, ilan ang difference nun? So, wala pang 2 meters. So, hindi kaya ng gravity. Lalo na kung may mga 10 meters away pa sa gravity tank, sa tanke mo yung faucet. So, may horizontal pressure drop siya. So, the low pressure limit must be used for the hydropneumatic tank system and delivery pressure of the pressure regulating valve on the pump discharge of booster system will determine that pressure. Generally, the minimum pressure to be provided at most fixtures is 8 psi and from 15 to 25 psi for water closet. Sinabi ko kanina, ginagamit ko lahat. So, sa faucet, mga may gripo, mga fixture na may gripo is 8 psi except dito sa water closet, 15 to 25 or 15 lang para mababa lang yung pump mo. Sa water closet yata, as a shower is 12 psi. Remember that this pressure are flow pressure, not static pressure. Now, friction head loss. So ito yung mag-determine kung kailangan mo ng pump. Okay. Water piping must be sized to limit the friction head losses in the piping system so that the highest and most remote water outlet will have the required minimum pressure for adequate flow during periods of peak demand. Okay. So, gumamit ka ng gravity tank, mga to. Ang 3-story, kaya. 3-story, ang yung lowest floor mo, makukuha niya yung minimum flow pressure, minimum pressure ng outlet ng faucet, ng fixtures. Sa second floor, bababa na. Sa third floor, mas lalong bababa yun. So, kailangan mo ng booster pump galing sa tangke. Yan. Mababa ang pressure mo doon, ng pressure pump, kung nasa baba lang siya ng water tank mo o yung gravity tank. Pero, pag mga yun nga, 10 meters away, 20 meters away, andun yung fixture mo, yung pinaka-remote water outlet mo. So, magkakaroon ka ng friction head loss o pressure drop sa piping na mas malaki kaysa doon sa nasa baba lang. Okay, kasi yung horizontal niya, liko-liko pa. Okay? Liko-liko, yung mga fittings, nagpaparami doon. The maximum pressure head loss that can therefore be tolerated in the system during peak demand is the difference between the static pressure at the highest and most remote water outlet at no flow conditions and the minimum flow pressure required of the outlet. So, pipe friction head loss is directly proportional to the length of run. A constant times the length of run. The longest length of run, the longest length or run to the highest outlet should be selected for purposes of sizing the system. Yes, the most remote. Ibig sabihin, pag sinabing highest and most remote outlet. Pag most remote lang, gravity ka, ang kinamang most remote, yung pinakababa. So, hindi yun. Yung highest na most remote. Kasi ito measure ang pinakamalayo, sabi doon. So, hindi yun. Dapat yung highest kasi andun yung pinaka-lowest, pinakamalaking pressure drop mo. O friction head loss. Head loss kasi in feet. Pag sabi pressure drop, that is in PSI. If the losses in this run of piping are within the required limit, then every other run of piping will also be within the required friction head loss. Okay, kung ayaw mo sumobra, may balbula naman. The selected longest length of run should be sized in accordance with uniform friction head loss distribution throughout its length for ease of calculation. It has been found that this method of uniform friction head loss calculation does not result in any significant variation of pipe sizes throughout the system. Okay. Yeah, any variation of pipe sizes throughout the system. This is the uniform friction head loss method. The permissible uniform head loss in pounds per square inch per 100 feet can be found by dividing the total friction head loss permitted by the equivalent of that of the longest run and multiplying by 100. Uniform friction head loss is equal to total friction head loss times 100 plus equivalent length of run. Okay, itong uniform head loss method, magagamit mo to sa kung yung main mo, direct ka sa main, wala kang pump, ang main mo is mataas, about 40 PSI, tapos ang pinaka outlet mo is 8 PSI. So 40 minus 8 divided by no equivalent length of run. Total pressure head loss mo, 40 minus 8 is 32. Diba mo ng equivalent length of run na 100, yun ang magiging ano mo, uniform friction head loss mo. Wait, this is divided by so ito yung pinakasimple. Pero kung wala ka namang pump, kasi kung may pump ka, mababa yung ano mo, so kung 8 PSI, 20 PSI minus 8 is 12. Tapos ang baba, nung magiging result ng uniform friction loss mo is masyadong mababa. Ibig sabihin, pag yun na maging design value mo, ang pipe mo malaki. Kasi pag low pressure, malaki yung pipe mo. So, kailangan ng mag-pump para lumiit. Eh, ano yung supply pressure ng pump? So, gamitin mo na doon is yung velocity method. Maximum velocity is 8 feet per second para sa cold water, 5 feet per second naman sa cold water. Babanggitin din natin yun. O nabanggit na yata. So, dito is yung pag masyado malaki lang yung main. So, double check nyo rin nung may pump. So, the equivalent length of piping is its developed length plus the equivalent length of pipe corresponding to the friction head losses for fitting, valve, strainers, etc. Okay? Pag meron kang tangke, papasok ng pump, alam nyo na yung standard Standard yan is gate valve tapos strainer, then pump tapos check valve tapos strainer. Okay? When the size of fittings and valves are known, the equivalent length can be found from table 4. So dito, first estimate mo lang ang uniform pressure. So dito, wala ka pang pipe size. When sizing a system, the size of fittings and valves are not known, and the under-protection losses imposed must be approximated. A general rule of thumb that has proven to be surprisingly accurate is to add 50% of the developed length to follow for all fittings and valves. Thus, equivalent length of run ALR is the developed length of run DL to DLR plus 0.5 times DL or EL is equal to 1.5 DL. So this is your first estimate. Pag na-compute mo na yung pressure drop, ito, first estimate mo to para makuha mo yung total equivalent length. Then use the equivalent longest and design value mo. Kung ang base mo is uniform friction head loss. Pero mas mataas, mas malaki ang time na nakukuha dito. Then, pag nakuha mo na yung pipe size niya, nakuha mo yung uniform ito, friction loss. Kung nakuha mo yung uniform friction and loss, then punta ka na sa makukuha mo na yung pipe size. May formula yan. Okay? May formula. Ito, may formula yan. O sa graph. So ito yung mga equivalent fittings. Screw fittings, ang ginagamit natin is 2 inches in below screw type for steel. So 2.5 and above is glass fitting. Okay? Kasi walang pipe feeder. Kung mayroon mahal yung pipe feeder, pag 2.5 pataas na. Okay? Sa PVC, NCPVC fittings, equivalent length and pipe, pwede mo rin gamitin sa PPR na hindi pa plastic. Ito naman yung mga value niya. So, dito, meron siyang mga elbow, fittings. Yung hindi available dito, gate valve, meron ba? Okay, meron siya. Yung strainer, saka andito siya, check valve, andyan. Tapos kunin niya dito. Okay. So, 2.5 inches na check valve, saka strainer, dito niya na kunin. So, for those who prefer to perform their own calculation, the following formula may be used. For brass and copper, Q is equal to 60.8 days 1/2 times P over L times 1/2. Galvanized iron or steel fitting, Q is equal to 43 times this 0.2 and 1/2 times P over L 0.1/2. Where Q is the quantity of flow, yung nakuha ni kanina, yung mga flow rate sa fixture unit equivalent. At every pipe, every section, meron makukuha mo yung flow rate doon. Then, P over L, ito yung friction loss mo per 100 foot. L 100, P is, so, yung value doon, yung PSI. Nakuha mo sa NPSI, divide mo na ito. So, okay, yung required pressure mo, divide mo ng length. So, yan. So, ano yung flow rate? So, solve for B. So, makuha mo yung diameter. When utilizing the above formula, it is important to use the actual internal diameter of the pipe rather than its nominal diameter kasi marami nakakalimot. The actual internal diameter of pipe of various material is given in Table 1 and Table 5. So this equation derived to ng reference. Ginagamit sa iba. Parang shortcut to. So meron din ibang formula, general formula yung ayan, Heisenberg formula doon to galing. So may factor yung steel, may factor yung copper. So derive na to. So pwede nyo itong gamitin. Yan. So wala ng velocity. So ang ginamit mo dito is uniform friction head loss. Ano yung tawag doon? Uniform friction head loss. Yun nga. Rating ko ulit, uniform friction head loss, masyado may mga oversized dyan, masyado malaki. Pag gumamit ka ng velocity, maximum, so iba-ibang head loss niya, friction loss niya. Pero yung pipe size mo, tama pa rin. Tama, saka maliit. So nag-limit lang siya sa 8 feet per second. Kung nag-ano ka ng friction dito, uniform friction head loss. So para maging uniform yung head loss niya, may yung yung bababa yung velocity mo, mayroong 4 feet per second. So pwede mo siyang paliitin pa. Kasi allowable naman is 8. So mas okay pa rin yung yung velocity method kasi so velocity method flow rate, makukompute mo yung type size agad. So makukuha mo agad yung equivalent length. So from minimum pressure or residual pressure na tawag dun sa outlet, i-add mo lang yon. So makukuha mo na yung pressure na required doon sa system. Tapos, kung anong difference doon sa main, saka doon sa required mong supply pressure, yun ang magiging head ng pump. So dito sa uniform, wala pa. So dito sa uniform, ginagamit ko, sabi ko, kung mas mataas yung pressure mo sa main, masyadong above. Check mo lang yon. Above yung yung main pressure mo, unless mo yung outlet pressure mo. Nag-divide mo ng distansya, yung equivalent length of band. So, yun ang magiging uniform pressure head loss mo. Okay? Ang unit niya is PSI per 100 feet. So, dyan, yun ang gamitin mong design. Tapos, nakuha mo yun, check mo yung velocity. Ang velocity mo sa buong system, walang umabot ng 8 PSI o puro 1, 4. So, doon ka na sa velocity method. Kasi baka masyadong mababa yung ginamit mo, masyadong malapit, masyadong mababa, masyadong malaki na yung pipe mo. Sabihin, yung minimum kasi, 2 feet per second, di ba? May minimum pipe yan. May minimum velocity. Tapos, kailangan lumabot ka ng 2 feet per second kasi nag-design ka. Kailangan yung pipe mo, yung velocity, hindi umabot ng lumabas ng 8 feet per second. Pwede ka na mag-10 pag outdoor kasi yung ingay, yung noise nga, noise. Pag indoor, that is 8 feet per second sa cold water, 5 feet per second sa hot water. So, size ng pipe mo doon is the minimum. And yun ang economical. Okay? So, yung reference natin ito is 1977 pa. So, ito yung mga fittings. Yan, ito na. Ito sa yan. Maximum velocity of water flow in the piping during period of fixed demand should always be of prime importance to the designer. As previously discussed, when flow approaches 10 feet per second in piping, serious problem can develop. High velocity produce noise in the form of whistling. The danger of hydraulic shock and water hammer is increased. The noise of cavitation may occur, and erosion and corrosion are increased. So it is for the reason that piping should be sized so as to never exceed a velocity of flow of 8 per second. Ayan, minayos lang. So, pag nag-base ka ng 8 per second, nakuha mo yung pipe size, check mo yung ano yung available minus less than sa outlet flow pressure. So, pag mababa kaysa din sa required pressure drop, asa na-solve nakuha mong pressure drop based on 8 per second, kailangan mo ng pump. Yun. Kaya nga, manipulate mo yung calculation dito. So, as an illustration of sample of working with formulas, as the following examples are offered. So, 1, for a demand of 100 GPM, a permissible total friction head loss of 16 PSI, an equivalent length of run of 100 feet. What size pipe is required for the following piping materials? Brass, type K copper, and type L copper. Example to. Using the formula for brass or copper, Q is equal to 60.8 times d exponent 2.5 times P over L exponent 1 half. D exponent 1 half is equal to Q times over 60.8 times P over L exponent 1 half. So D exponent 1 half is equal to 100 over 60.8 times 16. 16 over 100.1 half is equal to 4.11. So, merong mali dito. Wait. Okay. Ibalik na kasi mali. Ayusin ko yung format. Yan, okay. So, ito, D exponent 1 half. Lagyan ko ng bracket kasi yung presentation, di ba? Makakalito. 100 over 60.8 times 16 over 1 half is 4.11. So, referring to table 5, to determine values of D exponent 1 half, we find brass 2 inch, type K copper 2 inch, type L copper is 2 inch. Yung table 5. Ito. 4.11. 4.11. So, 4.11, ito wala dito, di ba? So, ito, 2 inches. Pasok sa 6.17, 5.37. So, lahat siya pasok. Pero ang question lang naman is brass, copper, and type K and L. Okay. Yan. Next, assuming a permissible friction head loss of 36 PSI and all other factors the same as in the above example, what are the sizes? So this point 1 up now is equal to Q over 60.8 times 36 over 100.1 up. Not Q. This point 1 up is 2.74. So yeah, 100 pala yung Q, 100 Q. So then brass is 1.5, type K copper is 2 inches, type L copper is 1.5. 2.74. Table 5, 2.74. So tama, 1.1 up yung brass. Copper type K, 2.74. So wala dito, kulang to. So next size ka na, 2 inches. 2.74 copper type L, pasok. So yan, 1.1 up. Okay. Ganun pag-select. Now, it can be seen from this example that material selection can have an effect on the size of pipe for a particular system. Minimum sizes. Morse code establish minimum sizes for the piping supplying the outlets for the various kinds of pictures. Table 3.1 list pictures and minimum size of pictures supply 5. Sizes given in the table are generally such as to maintain velocity of flow below the maximum 10 feet per second. So ito nga yung dating table, ito yung mga 5 size niya. Okay? Now, procedure for sizing. Before attempting to size any system, a Riser diagram of the complete quadrant distribution system should be drawn. Doon ka magbe-base. And the slicing diagram should be shown to floor height. It very often proves useful as to note the static pressure at its floor. On this drawing, note the minimum pressure required at the highest outlet as well as the minimum available pressure. This can be called step 1. Then A, step 1 or step A. Step 1. Your next step na is A, mark the FU values at every outlet and sum of picture unit for every section of the system. It is important to stress that when adding loads, it is mandatory to add fixture unit values. Never add gallons per minute demand except for continuous demand. Letter B, convert all FU values to GPM demand and assign the GPM values to continuous demand outlet. Letter C, determine the pressure available for friction head loss. Using the longest run to the highest fixtures, refer to plans as well as to the riser diagram for determining the longest run. Establish the uniform friction head loss. So D, using hydraulic table to select sizes. Selection will be based upon GPM demand, the uniform friction head loss, and maximum design velocity selected. If the size indicated by the table produces a velocity in excess of the selected maximum velocity, then size must be selected which produce the required velocity. Practically, all friction head loss tables are based upon Williams and Hessel formula. So, meron kasi mga available na tables. So, mas maganda pa rin yung formula. Kasi ano tayo, di ba? Sa Excel, pwede natin. Noon, sa table. So, ito yung Williams and Hessel formula. F is equal to 0.2083 times 100 over C exponent 1.85 times Q exponent 1.85 over D 4.8655. Lagi itong may encounter na sa piping. Where F is the friction head in feet of liquid per 100 feet of pipe. So, ang daming iba-ibang tsura ito. Tulad ito. This is also Hessel-Williams formula. Sa internet. Equivalent naman yan. If PSI is desired, multiply F by 0.450. Ito. So F times 0.450 magiging PSI. Okay. D is inside diameter of pipe. Q is the flow in GPM. C is constant, reflecting roughness of pipe. So dito mag-iiba-iba yung value of steel or copper or plastic. So Williams and Hessel formula employs the commonly used value for design purposes of C is equal to 100 for steel pipe and C is 130 for brass and copper. Maximum design velocity should generally be 8 feet per second and no velocity of 10 feet per second at which velocity noise becomes a problem. Should never be exceeded. So maximum friction head loss is the uniform head loss per 100 feet is determined exclusive of the basis of total pressure available for friction head loss and the longest equivalent length of run. Okay. So check nyo rin yung nakukuha mo uniform head loss per 100 feet Yung velocity niya baka magsobra. Okay? Merong case doon, di ba? 100 PSI available. So, lapit-lapit lang yun. 8 PSI to 100 minus 8. Tapos ang distansya lang pala, 4 meters. So, mga 12 feet. So, dinivide mo doon. So, ang laking uniform niyan dos per 100 foot. Ibig sabihin, ang laki no velocity mo. Diba? So, kaya nga, mas maganda yung velocity method. Tapos, check mo yung, saka magdadagdag ka ng pump pag kulang yung available pressure. Okay. So, ito, next, ano na lang ito? Next slide. Recording.